Skidamarinky-doo. Oh, hello there. Uh-oh. What is this crazy equation that Memes has on the screen? Well, y'all know what that means. We conjecture ahead!
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So, since we did the magnetic constant, excuse me. We did something else the other. I literally forgot what it was. It's been so long. I just woke up, did some stuff and things, did a little other this and that. Okay, what are we talking about today? Today, we're talking about E naught. It's a little E with a little sub-zero there. Oh, Sub-Zero, Mortal Kombat. Oh, jeez. How you can tell you're old. I played that stuff when it was in the arcade. But, okay. E naught. What the heck is that? Well, it's the magnetic constant, also known as vacuum permittivity. Again, links in the doobly-doo for anyone that cares to do a little bit of their own research, look into it. Okay. Vacuum permittivity, commonly denoted E naught, pronounced epsilon naught, or epsilon zero. Oh, it's not quite Monster Zero. Actually, wait a second. King Ghidorah, he kind of shoots electricity. It's actually gravitational beams, I learned. I always thought it was electricity because Godzilla didn't like electricity unless he liked electricity. The kaiju verse can be confusing, just saying. Is the value of the absolute dielectric permittivity of classical vacuum. It may also be referred to as the permittivity of free space, the electric constant, or the distributed capacitance of the vacuum. That's a lot of different names. Nobody would ever confuse them. It's an ideal baseline physical constant. The code data value is 8.8541878128. Error bars of 13 times 10 to the negative 12 farads per meter to the negative 1. Wow, that's a crazy thing there, isn't it? All right, so basically, when you do Coulomb's law, it comes out to be like this, and that kind of makes sense, I guess. We got the 1, because we already have that right here, so, yeah, 1 over 4 pi, because we're assuming a sphere, times the electric constant, so basically then you multiply it by charge 1 times charge 2, divided by the raise, yada, yada, okay. That's not what we're talking about today, just note that. Oh yeah, and the thumbnail, that's technically called a plasma ball, apparently. Those things that we used to have at, like, Hot Topic and Spencer's, like, you put your hand on it, and then all the things would kind of go towards you, and you're like, whoa, man, I'm not getting zapped. I always liked those. They were very expensive. But, okay. We don't need that. All right, so as we all know, we're looking for a number. There's that number here. We already just went over in Wikipedia. Okay, that's cool. But those farads and everything. Oh, actually, we should do Wolfram Alpha, shouldn't we? All right, let's do another Wolfram Alpha. Just to keep ourselves honest. Electric constant. Boop. All right, go Wolfram Alpha. All right. So it's normally 1 over the speed of light times the magnetic constant. Over there. All right. We got all that stuff. All right. So we got mass, -1, length, -3. Oh, yeah, it's got one of those current things. All right. So as we know, we've got our things. All right. Mass -1, length -3. Because this is essentially our boundary condition. So utilizing the universal binomial factorization equation, we have our primary action here. That's the 1 over 4 pi. Multiply it by our boundary conditions, also known as the ingredients of reality, whether it's time, space, charge, mass, or temperature. Coincidentally, those 5 delicious ingredients help make up our realm of persistence. Okay, then we multiply it by the terminal action, which is basically the action in which the inversion occurs, because that I've noticed right around about 7 significant digits, things start to not quite line up. We seem to run into some issues with these different constants with all these conversion factors. That's why you want a coherent system of units, Planck units. Because if we can do that, that makes a really big difference. And this is our inversion boundary here. So, excuse me, this is the terminal action, and that's usually 1 plus. In this case, we're actually subtracting this out. Oh, because in the other one, we kind of, we were adding things. So subtracting, kind of like in the hyperbolic vortex equation, we raise it to a negative pi divided by 2. We'll get into that in a second. So this is our terminal action, so 1. Then we're subtracting 4 pi, which is basically a sphere. And then, oh god, we get this crazy looking X with the 0 with its eye closing and stuff that we did the other day. Yeah, and that's raised to the 4th. Kind of like we did the other day. Okay, so this is J theta raised to the 4th. What is J theta? J theta is this thingy here. So basically, it's that, it's the 2, it's the positive 2. When we swap over to trig form of the complex solutions to, this is J3 here. Okay, so we raise that to the 4th. What the heck does that mean? Some may say we're lining things up orthogonally, because we're talking about electromagnetic stuff and things. Why? Coincidentally, right angles seem to be very important. Why? Well, if we're going to arrange orthogonally, we got a J theta here, we got a J theta here, a J theta here, a J theta here, squaring it up. You see, it wasn't quite a square, it was more of a rectangle. But I digress. All right. Oh, hey, welcome Whitechapel. Thank you for joining, my friend. I'm continuing to nerd out. But, okay. And then we multiply by the inversion boundary, which is Planck length times the Planck mass, all divided by the Planck charge squared, which coincidentally comes out to be right about, that 10 to the negative 7. Which is very interesting, which is right around things start to get wonky too. All right. So 1 over, basically a sphere, times our dimensional ingredients, times the terminal action over here. Okay. What the heck does that get us? Boom. Throw it in here. All right. We get that 1 over 4 pi. Yep. Planck time squared times Planck charge squared. Well, that's all over Planck length cubed, because we're talking about spheres and stuff and things, right? Yeah, it's 3-dimensional. And then times the Planck mass. All right. Terminal action, that 1, and then we're subtracting this out, so it's a minus 4 pi, and that's it, J theta right there. All right, raised to the 4th, and then times that 10 to the negative 7. We'll just divide it by 10, but to the negative 7. Gives us this number right here. Okay. So what's the number we're looking for? The number we're looking for is... Boom. Okay. Number we're looking for is 8.85. All right. 8.85 418 418 781 781, and we get to the last 2 digits. We have our 28 with outer bars of 13. So it'll be 8128. It's 8137. Oh, so if we subtract 13, that would be 24. Oh, that's 28. It's within the error bars. They're our best measurements of this current time. My friends, this looks like a geometric derivation of the electric constant. Now, there are some other things I need to talk to Thad about and everything. It could just be my errors and everything, but again, it's when you only have like a handful of folks working on something and you're trying to reverse engineer reality, or quote-unquote a theory of everything we're trying to reverse engineer. Hacking the universe with a MacBook Air. Again, full disclosure, this is a MacBook Pro. But, yeah, just putting that out there. So, hey, that's all we got for right now. Peace out, everybody. Take care of yourselves. It's a wacky and wild world out there, but I'm pretty sure there's going to be some really cool stuff coming. Take care of yourselves, everyone.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.